Hello everyone, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer quiz 2 question. Altogether, we have 4 different questions and let's start with the first one. Question number 1. You were given this equation with delta H equivalent to 822 kJ. How much heat is released by the above mentioned reaction if 11.4949 grams of sodium react completely with chlorine? Let's look at the question. So, the first information given to you is the mass of sodium. So, once you have the mass of sodium, the thing that you can do is you need to calculate the number of mole. So, the number of mole for sodium is equivalent to mass over RMM. The mass was given to you in the question, so it's 11.4949 divided by the RMM for sodium, which is 22.9898. Therefore, you should get the number of mole for sodium is equivalent to 0.5 mole. Right. And then we need to look at the balance equation given to you. So in the balance equation, it states here that 2 moles of sodium will produce this much heat or energy. So 2 mole of sodium shall produce positive 822 kilojoule. But you have less than 2 mole, you only have 0.5 mole of sodium. Therefore, how are you going to do this? Is 822 divided by 2 times 0.5. So you should get 205.5 kilojoules. So this is the final answer for the first question. Question number 2. In an experiment, an excess amount of solid magnesium oxide was added to a 50 cm3 of 3.0 mole per decimeter cube hydrochloric acid. The initial temperature of the solution was 21 degrees Celsius. After the reaction, the temperature has risen to 53 degrees Celsius. Determine the enthalpy change for the reaction of 1 mole of magnesium oxide with hydrochloric acid, given the specific heat capacity of the hydrochloric acid is equivalent to 4.2 joule per Kelvin per gram. Let's look at the question together. So the first thing that you need to understand is the value of Q is actually the same value of delta H. So you should know what is the formula for your Q. So delta H is having the same formula as Q, which is MS delta T. So the information given to you is mainly for hydrochloric acid. So the delta H that we are going to calculate now is actually for the hydrochloric acid. So in the question given to you, the mass of hydrochloric acid is 50 cm3. Therefore, at the mass here, you should write 50. And then going on to the specific heat for hydrochloric acid is 4.2. So you put here 4.2. And then look again at the temperature change. So the initial temperature of the solution was 21 degrees Celsius and it have risen up to 53 degrees Celsius. Alright, so what do you need to do with this is you need to look at your value for your heat capacity. So the heat capacity is actually in joule per Kelvin, right? So since you were given the temperature in degrees Celsius, you need to convert it to Kelvin beforehand. So the changes of temperature must be the final temperature minus initial temperature. So we are going to do like 53 plus 273 minus 21 plus 273. Alright, so from here you can get 50 times 4.2 times 32. So you should be able to get 6.72 times 10 to the power of 3 joule. This is just for hydrochloric acid. Right, let's see. Now, you were asked to determine the enthalpy change for reaction for 1 mole of magnesium oxide, right? So we need to know how many mole of magnesium oxide that is really in here. So we need, in order for you to do that, we need to know how many moles of your hydrochloric acid is available in this kind of reaction. Given to you in this question is the molarity of your hydrochloric acid. So molarity is equivalent to mole over liter. So from the question, you know that the molarity for your hydrochloric acid is 3.0. So you know you can write here 3.0 equivalent to mole over liter. So because you only have 50 centimeter cube of hydrochloric acid, so 50 centimeter cube is equivalent to 50 milliliter. So you want to convert it to liter, so 50 divided by 1000. So you will get your number of mole for hydrochloric acid is equivalent to 0.15 mole hydrochloric acid. Alright, the next step that you need to do is you need to write the balance equation between the magnesium oxide and also the hydrochloric acid. So basically, magnesium oxide will react with HCl to produce water and also the magnesium chloride. So from here you can see that you have 2 chlorine, right? So means that we need to make it balanced, so we need to put 2 around here. So from here you can see that 2 mole of hydrochloric acid will need to react with 1 mole of magnesium oxide in order to produce the product. But from our calculation, we only have 0.15 mole of hydrochloric acid. So 0.15 mole of hydrochloric acid. So how much magnesium oxide that we need to have in order for us to produce the product? So 1 over 2 times 0.15. So you should be able to get the value of 0.075 mole of magnesium oxide. Alright, so from here we can use the value of the delta H that we already calculated in the beginning of the question here. So we use this and plug it in the balance equation that we have written just now. So in other words, we can say that magnesium oxide plus 2HCl will produce water and also magnesium chloride, right? So it means that for this reaction, the delta H should be equivalent to 6.72 times 10 to the power of 3 joule. So bear in mind that the unit here is in joule, not in joule per mole, because the number of mole for magnesium oxide that we have for this much delta H is actually for 0.075. So in other words, we can say that 0.075 mole of magnesium oxide will produce 6.72 times 10 to the power of 3 joule. But in the question, you were asked to calculate the enthalpy change for the reaction of 1 mole of magnesium oxide. So you want 1 mole. So 1 mole of magnesium oxide should be equivalent to 6.72 times 10 to the power of 3 divided by 0.075. So from here, you should get 8.96 times 10 to the power of 4 joule. So you can convert this into kilojoule. So plus minus, you will get 90 kilojoule. Alright. We are not going to end here because we need to check whether this is an exothermic or endothermic process. Right, so from the question you can see that initial temperature is 21 degrees Celsius and the final temperature is 53 degrees Celsius. It means that the temperature is increasing. So when the temperature is increasing, it means that it is an endothermic process. But you need to understand that the endothermic process is being for the hydrochloric acid only, because this consists of two different things, two different reactants, which is the magnesium oxide and also the hydrochloric acid. So since the hydrochloric acid is an endothermic process, therefore your magnesium oxide should be an exothermic process. So your delta H for the magnesium oxide should be an exothermic process, which is negative 90 kilojoule. So this is the final answer for the second question. Let's move on to question number 3. Methanol is an important fuel that can be synthesized from carbon dioxide. The table below shows some standard enthalpy of formation. A student carried out an experiment to determine the change when a sample of methanol was burned. The student found that the temperature of 140 grams of water increased by 7.5 Kelvin when 0.011 mole of methanol was burned in air and the heat produced was used to warm the water. Determine the enthalpy change when 1 mole of methanol was burned, given that the specific heat capacity of water is 4.18 joule per Kelvin per gram. Alright, in order for us to answer this question, we are going to use the same approach that we used in the previous question. So we are going to use the formula of Q is equivalent to MS delta T. So given to you, the mass of water is 140 grams, the specific heat is 4.18, and the change of temperature is 7.5 Kelvin. So if you look at the unit for all of these, they are in the correct unit. So we can just plug in the value of this. So the mass will be 140 grams, specific heat is 4.18, and the change of temperature is 7.5. So from there you can get the value of Q is equivalent to 4.3890 times 10 to the power of 3 joule. This is the value of Q. So how much is this? So because in here you see it in the question, it states here that 0.011 mole of methanol was burned. So means that the value of Q here is for 0.011 mole. So what we can do is 0.011 mole of methanol will produce 4.3890 times 10 to the power of 3 joule. So you were asked to calculate for 1 mole. Right? Therefore, 1 mole is equivalent to 4.3890 times 10 to the power of 3 divided by 0.011. So you should be able to get the final answer equivalent to 3.9900 times 10 to the power of 5. This is in joule. But if you look closely in your author, the choices of answer is in kilojoule. So this value you need to divide by 1000. So you should be able to get the final answer is 399 kilojoule. But remember, this is for 1 mole. So the unit that you need to write is kilojoule per mole. So this is the final answer for the third question. Right, let's move on to the second part of question 3. So I'm just going to read the last statement. Determine the enthalpy change for the formation of methanol. So the rest of the information are the same, only that the question differs, which needs you to calculate the enthalpy change for the formation of methanol. In order for you to answer this question, the first thing that you need to do is you need to be able to write a balance equation for the formation of methanol. So the formation of methanol is from the carbon dioxide plus hydrogen. You will produce the methanol and also water. And if you can recall, what is the formula for the to calculate the enthalpy change of formation? So delta H formation is equivalent to the summation of delta H formation of the product minus the summation of delta H formation of the reactant. It's just the other way around from the enthalpy change of combustion. Alright, so here you need to know this is your reactant and this is your product, and then you're going to match it with the values given to you in the table here. So if you look at the table here, there's no value for your hydrogen. So basically hydrogen is an element, so the value for your delta H is actually equivalent to 0. So what we are going to do now is we are going to plug in the values inside this equation. Alright, so we are just going to plug in all this value. So at first we are going to look at the product side. So the product will be the methanol and also water. So methanol is negative 201 and water is negative 242. So what we are going to do here is just negative 242 plus negative 201, right? So this is for the product side minus the summation of whatever in the reactant, because the hydrogen is an element, so we only left with carbon dioxide, so we only have negative 394. So from here you should get negative 4.43 times 10 to the power of 2 minus negative 394. Therefore you should get the enthalpy change for the formation of methanol should be equivalent to negative 49 kilojoule per mole. So this is the answer for the third question, section D. Let's move on to the final question. Question number 4. Determine the enthalpy of formation for the equation below, given that the heat of combustion of carbon, hydrogen and methane at 298 Kelvin and 1 atm are negative 393.5 kilojoule per mole, negative 285.83 kilojoule per mole, and negative 890.36 kilojoule per mole respectively. Since this is a Hess law question, so you need to be able to write a balance equation for this carbon, hydrogen and methane, and the reaction that they have been gone through is a combustion reaction. In a combustion reaction, you need to understand that the reaction will go through with the reaction with oxygen. So it means that carbon will react with oxygen, hydrogen will react with oxygen, and methane will react with oxygen as well. So how are you going to write the balance equation? Let's do it together. We shall start with carbon. So the combustion reaction of carbon is carbon plus oxygen shall produce carbon dioxide, and the delta H is equivalent to negative 393.5 kilojoule per mole, just like stated in the question here. Alright, so the next thing you need to do is you need to look at whether or not this equation is balanced or not. So you have 2 oxygen at the product and 2 oxygen at the reactant. and one carbon at the reactant and one carbon at the product. So this is a balanced equation. Is hydrogen. So same drill, hydrogen shall react with oxygen to produce water with the delta H of negative 285.83 kilojoule per mole. So bear in mind that the unit is in kilojoule per mole. So it means that since that we are looking at the hydrogen, do not change the number of mole of hydrogen. So if you were to balance out this equation, you need to try to balance out with using other things. For example, here we do have 2 hydrogen and 2 hydrogen at the reactant and also the product. But we have 2 oxygen at the reactant but only 1 oxygen at the product. So instead of changing the hydrogen, you need to adjust your oxygen. So you need to do 1/2. So half times 2, so become 1. So this is the balanced equation for the second one. Alright, so we are going to do the last equation, which is for the methane. So CH4 plus oxygen, because it's a combustion reaction, so it will produce carbon dioxide plus water. This is just a normal hydrocarbon combustion. So delta H is equivalent to negative 890.36 kilojoule per mole. Okay, same drill. We need to make sure that these equations are balanced, but make sure that you don't adjust your methane. So here you have a total of 3 oxygen. So you have 2 plus 1, so 3. Here you only have 2 oxygen. So if you were to times 2 here, so means that 2 plus 2 equivalent to 4. So you can have 4 oxygen around here. So this one times 2. Okay, let's check for your hydrogen. 2 times 2 equivalent to 4, and indeed you have 4 hydrogen at the reactant. So this is a balanced equation. Alright, so what's next? So we need to look at each and every equation and match with your target equation. The target equation is given in your question, which is this one. Alright, so what you're going to do now is you're going to make sure that this equation that you have written matches the target equation. Alright, so we're going to look at the first equation. The first equation, you have carbon, oxygen, and also carbon dioxide. So the carbon is indeed needed in the target equation, and it is indeed in the reactant, and you only need 1 carbon, and this is 1 carbon. So we consider that the first equation is okay. So next up is we're going to look at the second equation. So in the second equation, you do need the hydrogen, and the hydrogen is indeed in the reactant. But you need 2 hydrogen around here to match with the target equation. So what you're going to do is that you're going to times everything here with 2. Next, we shall look at the final equation. So methane is indeed needed in the target equation, but the position of methane is not the same as the target equation. So in the target equation, the methane should be in the product instead of in the reactant. So what we can do is we can switch up all this. So when you switch this up, means that you need to change this from negative to positive. So what we are going to do now is we are going to rewrite this equation so that it matches the target equation. Alright, now we already transfer all this equation here in accordance to what we need to do to meet the target equation. So what do we need to do now is we need to slash out all the similar information from the reactant and the product so that we can get exactly like the target equation. So for example, here we do have 2 oxygen on the product and we do have 2 oxygen in the reactant, so we can slash that out. So another one is the carbon dioxide. We have one here in the reactant and we have another one in the product. So what else that we can slash out is the water. So we have 2 water at the reactant and another 2 at the product. So if we compare with the target equation, now we only need carbon, hydrogen and also methane, and it is indeed the same. Alright, so we have got the carbon with 2 hydrogen and methane. So how are we going to calculate the delta H? So the delta H is just the summation of all the delta H that you have here. So when you do the summation of these values, so you should get your delta H for your target equation should be equivalent to negative 74.8 kilojoule per mole. Right, so this is the final answer for the last question for quiz 2. Thank you so much for watching this video. I hope this video helped you to understand more on how to answer the quiz 2 questions. So I'll see you again next week. Take care and goodbye for now.